In this tutorial, I'm going to solve this problem taken from Abaqus documentation manual, where I have a hinge part and a pin part, and I will be loading the structure over here. For solving this problem, we have these 13 steps to create and analyze the model and to view the results. Our first step is overview of the model. Step 2, creating the first hinge piece. Start with Abaqus standard, create part. I will call this as hinge hole 3D deformable extrusion, and maximum dimension is 0.2. Click continue. The first thing is to create a rectangle. Let us create this rectangle, and then I will dimension it so that I can create a cube. Create the dimension 0.04. Create the vertical dimension 0.04. Click done, and the depth of the section is 0.04 because this is a cube. Adding the flange to the base feature. Then I will add this flange to the base feature. For adding the flange, go to shape, extrude, click on this surface and click on this line as the right side. I will start from here and create any line. Click here, and then click here and click here. Then I have to assign horizontal constraint to these two lines. Click on constraint, horizontal, and click, this is already horizontal, and then I will assign equal length constraint. Click on constraint, equal length, press shift key, click on this line, click on this line, you have equal length constraint. And then I will dimension one line as 0.02 meters. Then you can observe that 0.02 has been assigned to both lines. Then I will create arc over here. Click on create arc, 3 points. Click on this point, click on this point, and you can click pretty much anywhere you like. I'm clicking it here. Then I will assign a tangent constraint over here. What it will do is that it will make this line and this curve as tangent to each other. Click on constraint and tangent. Click on first entity, this one, second one is this one, and then again click on this line, second line is this one. A tangent constraint is assigned over here. Next, I will create a circle. Create on circle, center and perimeter. Roughly put it anywhere over here, and then we will make it concentric. Click here, and then click here. Then I will dimension this circular region as 0.01. After that, I will assign a concentric constraint to both these circular regions. Click on the first instance, click on the second instance. Now both of these circular regions are concentric. Click done. I will flip the direction, extrusion direction. The depth of extrusion will be 0.02. Click done. I missed something over here. If I double click, I want to keep the internal boundaries. What it will do is that it will have a different boundary for this flange section, and it will be separate from the cube section. Click here, apply, and all right. Now it has created a separate boundary for the flange region and is separate from the cube region. Modifying a feature. Now here we have created two regions. One is solid extrude 1, which is the cube feature. Another is this flange feature. I want to modify the dimension of this circular region just to demonstrate that how do we modify the section geometry. So click on section, click on sketch here. I want to modify this radius to 0.012. So click on edit dimension value, click here 0.012. Now you would argue that why didn't we do it at the first place? The reason was that because in the documentation, we want to show that how can we modify the section if we have made a mistake somewhere. Click OK. Now you can see that the radius of the circle has changed. Click done. We have to regenerate this feature. So click on feature and click regenerate, and then it will display the results afterwards. You can see that the radius of the circle has changed now. Creating the sketch plane, which is needed to create lubrication hole. We will create three things. First, I want to create a datum point, which is at 45-degree angle from the center of the circle. Second, I want to create a datum axis, which passes through the center of the circle all the way through this datum point. And third, I want to create a datum plane, which passes through the datum point, and it is at 90 degrees to the datum axis. In that way, I'll be able to create this hole. For achieving this, I will click on create datum point, and I will click on create datum point, enter parameter. Click on this line. Arrow is pointing downwards. I want to create a point which is at 45 degrees. It means that it has 25% distance from this point. If the arrow was other way around, then I will say 0.75, but here I'll say 0.25. A datum point has been created. Next, I want to create datum axis. Click on datum axis and click on datum axis 2 points. I want to create a datum axis between this point and the center of the circle. Now I want to create a datum plane which passes through this point and it is normal to the datum axis. Click on planes and click on create datum plane point and normal. This is the point where I would like my datum plane and normal is this datum axis. Sketching the lubrication hole. Next thing I want to do is I want to create a lubrication hole that extrudes a circle from the datum plane. First, I need to create a datum point which is at the center of this part. For this, I will have to create another datum point on this line, and then halfway between these 2 points, I will have a datum point that indicates the center of the lubrication hole. So click on create datum point, enter a parameter, click on this line. Arrow is pointing upwards now. It means that now it will be 0.75. It means it will create a datum point at 25% of the distance from the top. And now I will create a datum point which will be center of lubrication hole. Click on create datum points midway between 2 points. Click on this point. Click on this point midway between these 2 points. It is the center of lubrication hole. I will go to shape, cut and extrude. It will ask me for the plane. I will choose this plane, and then vertical on right, I will choose this line. Click on create circle, center and perimeter. This is the center and circle has been created. Add dimension. Radius is 0.003. The lubrication hole has been created. Click cancel and done. Now I want to create the end condition as up to a surface. I will change the direction of extrude because I want this hole to extrude inside. It will ask me to select the face. To extrude to, I will select this face. Now you can see that this lubrication hole is created. Step 3 is to define material properties and section properties and assigning those section properties to the hinge part. So first we'll create the material and then section properties, and then we'll assign those section properties to the hinge part. This is very simple. Double click on material, steel, mechanical, elastic, 200E9, 0.3. Click OK. Material has been defined. Section, I will say solid section. Continue. Choose steel material, click OK, and then section assignment. Double click on section assignment, click on this surface, done, and assign this solid section. In that way, we have defined material and sections. We have assigned the section as well. Step 4, creating and modifying a second hinge piece. For creating second hinge piece, simply we will copy this, copy and rename hinge solid. Click OK. Here it has got all the features that we have created in the first part, except that it doesn't have lubrication hole. So simply I will go to feature and I will delete this cut extrude. Delete it. OK to delete, yes. This part has been created. Step 5, creating the pin. Double click on parts, say pin. It is 3D, analytical rigid and revolved shell. Approximate size is 0.2. Here I will create a line, a vertical line. I will create a horizontal distance between this point and this point. It is 0.012. I will also create a dimension for this line, which is 0.06. Click OK and then cancel the procedure. Click done. It will create a pin for me. Assigning the rigid body reference point. Now I will assign rigid body reference point to the pin. Click on tools, click on reference point and click on this point. Rigid body reference point has been assigned now. Step 6, assembling the model. First, I will create instances of hinges and then pins. Double click on instance, apply, then solid, hinge solid, that is offset from other instances. Click OK. These 2 instances have been defined. Here, I want to deactivate these reference planes. For this, click on view, click on assembly display options and click on datum. Here I don't want to see datum points, I don't want to see datum axis planes, and I don't want to see the coordinate system as well. Now we have to position these hinge pieces in such a way so that they act together and they have a pin in between them. So for this, first I will create face-to-face constraint. Click on constraint, face-to-face. Movable part is this one, fixed part is this one, and make sure that the arrows are pointing towards each other. And then distance is 0.04, because these two faces, they are not attached to each other. There is a distance because we have a flange over here. So this is 0.04. These two faces are face-to-face now. The next constraint is coaxial. So click on constraint, coaxial. Here, movable part is this one, fixed part is this one. Make sure that you flip the arrows, otherwise they will not be assembled properly. So flip arrows, this is downwards and this is rightwards. Now these two parts are assembled together, but these parts are sliding on top of each other. To remove this, I will simply use edge to edge constraint. So click on this edge, click on this edge. They should be pointing towards the same direction, and in that way you'll be able to assemble the parts properly. Now at this point, I would like to create the pin instant. Double click on instance and pin is away. I want to assign coaxial constraint. So click on coaxial, click on this instance, click in here, click OK. You can see that pin is inside the flanges, but I have to move this pin slightly so that it is exactly at the center of hinge parts. For this, tools, query, distance. I want to see the distance between center of the pin and center of the flange. First, I will choose this point and this point. It is 0.01 meter away. It means that I have to move this pin by 0.02. In that way, that pin will be central to these parts. Because the distance from here to here is 0.04, the pin is 0.06 meter long. I need overhang of 0.01 on both sides. The distance between center of the pin and the end over here is 0.01. It means if I move it by 0.02, I will have overhang of 0.01 on both sides. Go to instance and translate. Click on this to translate. First point is 0. The next point in Z direction is 0.02 and click done. Click OK. Now you can see that it is exactly at the center. In that way, we have created this geometry. Step 7, defining analysis steps. And I will define two additional steps here. One is for contact and other is for applying load. Go to steps. First is contact, static journal step, continue, establish contact. Incrementation, I want initial size to be 0.1. Click OK, step has been defined. Second step is load. Static journal step, click continue, apply load. Incrementation, initial increment is 0.1. Click OK, step has been defined. Step 8, creating surfaces to use in contact interactions. So go to assembly surfaces. First, I want to define pin. Click OK. I want to define the brown surface. The pin surface has been defined. I want to define flange H and flange S. These are two surfaces that come into contact with each other. For this, I have to deactivate some parts. So first, flange H. I will click on create display group, and here I will simply activate the hinge hole. Replace. Click on surfaces, flange H, click continue, and I want to define this surface. Click done. Next, I want to define flange S, that is the solid surface that is coming into contact with pin. Click on display groups. Now I want to view hinge solid. So replace, and this is the inside surface that is coming into contact with other hinge. So I will say flange S, click continue, click on this surface, click OK. And then I will use this opportunity to define inside S as well. So I will say inside S, click continue. This is the inside surface of the solid part. Then I will display the hinge hole part again. Click on surface, inside dash H, click OK. Find the surface. These surfaces have been defined. Click on create display group and shift all. I want to replace all. And if you click on these surfaces, you'll be able to see flange H, flange S, inside H, inside S, and pin. Step 9, defining contact between regions of the model. Here I will create 3 interactions: hinge pin hole, hinge pin solid, and flanges. First, I have to define interaction property. Click on interaction properties, say no friction contact, click OK. Click on mechanical, tangential behavior is frictionless, click OK. Creating the interactions. Now you can create the interactions individually, but here I will find the interactions automatically. For finding the interactions automatically, click on interactions, find contact pairs, and click on find contact pairs. You can see many surfaces have been found. First, I don't want any contact between the outside surfaces. I will delete this one. This is fine. I don't want any contact for outside surfaces, so I will delete that one as well. The first surface is flanges, where these flanges are meeting with each other. Discretization, I will change it to node to surface. Second is hinge pin hole and discretization node to surface. Third is hinge pin solid and discretization is node to surface. Click on hinge pin hole, click on initial, master surface is pin, slave surface should be hinge hole, and finite sliding, discretization, master surface should be pin. For hinge pin solid, again click here, click on initial, master surface is pin, slave surface is inside S, and node to surface, I will accept all defaults. And then for flanges, click here, initial, click on hinge hole as master surface and hinge solid as slave surface and click OK. Step 10 is applying boundary conditions and loads to the assembly. There are 4 boundary conditions that I need to define: fixed, no slip, constraint, and pressure. First, let us define fixed boundary condition: displacement, rotation. Click OK, and here I will define this surface. Click continue, select this surface and constrain u1, u2, and u3. I'm not constraining the rotation. I will use the solid elements in such a way so that I don't need to constrain these boundary conditions. Next, I want to constrain the pin. Click on boundary conditions. I will say no slip. Click OK. I want to select this rigid reference point of the pin. Click OK. I want to constrain all the boundary conditions here. Click on boundary conditions manager. I want to modify this no slip boundary conditions of the pin when I'm at loading. So click on edit. Here I want to ensure that this pin can move in X direction and it can rotate in U2 directions. This is the pin. It can move in this direction and it can rotate as well. Click OK and dismiss. Constraining the solid piece, double click on boundary conditions and say constrain. Click on the node, click OK, and constrain these 3 boundary conditions. And then I want to modify this boundary conditions so that hinge is unconstrained in X direction in load step. Click on manager. I want to edit this and I want to unconstrain this boundary condition in U1 direction. Next is loading. Double click on loading and then say pressure and pressure. Click on this surface. Continue, -1 e raised 6. Pressure has been applied now. Step 11 is meshing the assembly. But before I go ahead with meshing the assembly, I need to convert all the constraints permanently. Otherwise, if I needed to partition any instances, then my assembly is going to be disturbed. So go to constraint, here convert constraint, select all the instances, all position constraints that were here, they have now been converted. Now I will mesh the parts. Mesh will be dependent on part. So I will go to part first, hinge hole first of all, go to part and mesh. Green indicates that mesh can be structured mesh. Orange indicates that it requires further partition, and yellow indicates that it can be meshed only with sweep technique. So let us first of all partition this flange part. So go to partition, select cells to partition, and I want a cutting plane. So partition cell, cutting plane. Select flanges, and I would like 3 points. One is this point, other is this point, and third is the bottom point. Click partition. You can see it has turned yellow from orange. Yellow means it can be partitioned using sweep technique. Go to mesh controls and click on this part first, structured mesh hexagonal elements. Click OK. I will go to this part again. Done. Here I would like sweep mesh technique and medial axis. Click OK. And element types, reduce integration elements. Click OK. seed part, I will use 0.004. Click apply and click on mesh and mesh part. In the same way, I will click on Hinge solid. Here I don't need to partition this because it's yellow already. I will go to mesh controls, click on this part, structured solid, and mesh controls again. Click on this part, sweep technique, medial axis, click OK. Element types, I want to use these reduced integration elements, part seed 0.004, click OK, and then mesh part. A pin is an analytical pin and it does not require any meshing. And if you wanted to have a look at assembly, you can see that parts have been meshed now. Step 12, creating and submitting a job. Here I will create a job. I will say pull hinge, click OK, description, hinge tutorial, click OK, click on submit, monitor. So step 1 is completed, which was contact, and step 2 is completed as well. Click OK, and here I would like to have a look at its results. Make sure you are at the last step, and here I will change the scale factor to 100, and if you want it, you can have a look at hinge hole only.